Hello, grade 7. This is Mrs. Lopez. Today we are learning about lesson 7 in our module 2, addition and subtraction of rational numbers. Now, rational numbers are a little bit more difficult to work with because they are going to be positive and negative, mixed numbers, and decimals, and fractions, obviously. So if you don't remember how to add and subtract mixed numbers, fractions, or decimals, please review those on YouTube. Um, and that will help you a lot when you're working with positive and negative numbers. Okay, so the rules are the same. We are adding and subtracting. A subtraction again doesn't exist. We will need to change subtraction into addition of the opposite. That's the only rule that we are using. Okay, so suppose the 7th grader's birthday today, and she is 12 years old. How old was she 3.5 years ago? Write an equation and use a number line to model your answer. Okay, let's start with the number line to make sure that we understand where everything is um, happening. Okay, so we cannot have a negative age, so I'm going to start at 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where she is right now. So 1, 2. Okay, that's where she is right now. So from 0 to 12. Okay, now we need to see how old she was 3.5 years ago. 3.5 years ago would go back to the left side, right? So we'll go 3 and 1/2 more, resulting in 8.5. Okay, now let's change this model into equation that we know. What does that first arrow represent? First arrow represents 12 years, right? Then we are adding another arrow. We are adding it, so it's addition problem. We are adding another arrow. Another arrow is going to the left, so it will be a negative number. It will be negative 3 and 1/2 plus negative 3 and 1/2. So 12 plus negative 3 and 1/2 is going to be 8 and 1/2. How does that happen? Let me show you if you don't remember how to subtract numbers. Since we are subtracting the two numbers and keeping the sign of the bigger arrow or the bigger absolute value, we are going to subtract from 12, and I'm taking away 3 and 1/2. The reason why I'm going to write it this way is because I need to see that I am subtracting 1/2 from no fraction at all. So I will have to borrow 1 whole from 12, making it 11, and 1 whole that I borrowed, I will have to split into 2 halves to be able to take 1/2 out. So 11 and 2 halves is a 12, right? So we know we did it correctly. The one thing that people always forget is to split that 1 whole into the fraction part. So 2 halves minus 1/2 is going to give us 1/2, and 11 minus 3 will give us 8. That's how we have 8 and 1/2, and because 12 was a positive number, our answer is also positive. Okay, representing sums of rational numbers on a number line. Place the tail of the arrow on 12. Okay, so this one is telling us how to do it exactly. So I just showed you, so I'm going to just skip that one. We'll just go back to our model that we drew here and just go through the steps. Place the tail of the arrow on 12. So we drew an arrow and the tail of the arrow is on 12. The length of the arrow is absolute value of -3 and 1/2. Absolute value of -3 and 1/2 is +3 and 1/2. The direction of the arrow is going to be to the left. So we are going to the left, 3 and 1/2. And then draw the number line model to, in the space below. We did it above, so we are good. All right, moving on. Exercise 2. Find the following sum using a number line diagram. -2.5 plus 5. Okay, we know that uh, um, the sum is not going to change if we change the addends around, right? So if I did, let's say, 2 plus 3, it's the same thing as 3 plus 2, isn't it? We know it from the first grade. However, one of the numbers is negative. It's not going to affect our sum. I can change these numbers around and my sum is still going to be the same. The only difference is that the diagram is going to be looking different from when you're, if you draw 2.5 and then you will have to go, sorry, -2.5 is going to be here, and then you'll have to go 5, you'll have to count by halves. What I'm saying is it will be easier for you to start with a whole number when you're adding. So start with 5 and then add -2 and 1/2. Okay, that'll be a lot easier for you to count. So let's start at 5. From 0, we are drawing a vector to 5. From 5, we are going to add another arrow going to the left because we have a negative number. We are going 2 and 1/2 more. Again, that's going back to um, so that's how you would show -2 and 1/2 more. So we are going both to the negative direction to the left, and so we will have a number that is 2 and 1/2. Okay. All right. Representing differences of rational numbers on the number line. So now we're talking about subtraction. Remember, again, subtraction, we are going to just skip subtraction. We don't have to worry about one more rule. We change all subtraction into addition of the additive inverse, or the opposite. So here we have 1 minus 2 and 1/4. Instead of this subtraction, we will do 1 plus -2 and 1/4. Okay? All right, so we will start with 0 and we will go with our vector to 1. It'll be easier for us to start with a whole number, no matter what number comes first here. And we are going to add another arrow going to the left that is -2, so we will draw -2. So right now we are at -1, but we also need to go 1/4 more. We are not done there. So we'll have to separate one whole right here into 4 spaces, 4 units, making it -1/4, -2/4, -3/4, and -4/4 is going to be -2. So we'll go 1/4 more to the left, and we will stop at this number, which is -1 and 1/4. -1 and 1/4. Okay. All right. Next one. What steps did you take to solve this problem? So what did we do? We start at 0, draw a vector to 1, stop at 1. Then we start at 1, start at 1, draw a vector 2 and 1/4 units to the left. Stop at -1 and 1/4. Those were the steps. Okay. Before I go into exercise 3, I want to just very quickly review how would you subtract these two numbers without using number line. I know it might be um, a little bit ahead, but I just want to see, I want to show you how to do subtraction if you don't remember it. So let's go back to 5 plus -2 and 1/2. Because two numbers have opposite signs, I'm going to subtract from a higher absolute value. Higher absolute value is 5, so I'm going to do 5 minus 2 and 1/2. I'm going to write it this way because 1/2 has to be subtracted from something that we don't have. I will have to borrow from 5. 5 becomes a 4, and the one that I borrowed I split into 2 halves to be able to take 1/2 out. 2 halves minus 1/2 is going to be 1/2, and 4 minus 2 is 2. So that's how I get 2 and 1/2. I know it's going to be positive because my first number that I subtracted from is positive. Second one, the higher absolute value is -2 and 1/4, so I'm going to subtract from 2 and 1/4. I'm using the absolute values, remember. I know that this number is negative, so I know that my answer is going to be also negative, and I'm subtracting 1. Okay, so this is a different situation. I'm subtracting from 2 and 1/4, and I'm subtracting a 0, right? So I will have 1/4 left out, and 2 minus 1 is 1. Because I was subtracting from a negative number, -2 and 1/4, my answer is also negative. Okay, this is just a quick review into subtraction of fractions. Okay, exercise 3. Find the following difference and represent it on a number line. Okay, so right now I have -5 and 1/2 minus -8. This is a subtraction problem. I don't need it. I'm changing it into an addition problem. -5 and 1/2 stays, and I'm changing subtraction to plus. -8 changes into +8. Now notice, remember I told you it's easier to start from a whole number. So I'm going to change the order of these two addends, and I will do 8 plus -5 and 1/2 instead. Okay, so I'm going to draw a vector from 0 to 8, and now I'm adding a negative number, so I'm going to go to the left 5 units and 1/2 more. I will have to split my whole into half, and 1/2 more will be right here, which is 2 and 1/2. How would it look if I were subtracting it? I would subtract from 8, 8 minus 5 and 1/2, and I'm subtracting from 8 because 8 has a higher absolute value. I cannot take away 1/2 from nothing, so I'll have to borrow from 8. 8 becomes a 7, but the one that I borrowed I will split into 2 halves and take 1/2 out, resulting in 1/2. 8 minus 5 is 2. 2 and 1/2 is going to be positive because 8 is a positive number. All right. Okay. Find the following sums and differences using a number line diagram. Okay, -6 plus 5 and 1/4. Let's start from 0, go to -6. Okay, and now my next arrow is going to be 5 to the right. Okay, and now I'm going to go 1/4 more. So I need to split my whole into fourths and go 1/4 more, just like that. I'm going to stop at -3/4. It's a -3/4 because I always start at 0, right? -1/4, -2/4, -3/4 right here. So my answer is -3/4. How did it happen? I'm subtracting from the 6, 6 minus 5 and 1/4. I subtract from 6 because 6 has a higher absolute value. The number is negative, so I will have a negative sign in my answer. 1/4 cannot be subtracted from a 0, so I will have to borrow from 6. 6 will become 5 and 4/4 because I need to split that 1 to be able to get 1/4 out. 4/4 minus 1/4 is 3/4. 5 minus 5 is 0, negative sign. That's how I get negative 3/4. Next one. Here we have a decimal number. 7 minus negative 9/10. And I will just make that period a little bit bigger, decimal point. Okay, so we don't do subtraction, we change subtraction into addition. 7 plus positive 9/10. Okay, to draw it, I will draw a vector from 0 to 7. And my 9/10 is now positive, so I will have to go 9/10 more. To go 9/10 more, I will have to separate my whole into 10/10. My space doesn't allow it. I will just go up to like almost 8 here. Here we go. Oh, sorry, I had to add it on right here instead. Sorry. Okay, so I stop at 7 and 9/10, isn't it? 7 and 9/10. I can write it as a decimal because I'm working with a decimal number. Okay, to be able to show you how we do addition of decimals, 7 plus 0 and 9/10. We will have to make sure that we have that decimal in a 0 with the 7, and 9 goes after the decimal, so it will be a different decimal place here. This different alignment. 0 plus 9 is 9. We need to line up our decimals. 7 plus 0 is 7. That's how I end up with 7 and 9/10. Okay, next one is tricky because numbers are, one is a decimal and one is a fraction. 2 and 5/10 plus negative 1/2. How can I rewrite that to make it easier for me? 2 and 5/10. How can I write 2 and 5/10 using a fraction? 2 and 5/10. And 2 and 5/10, if I simplify that fraction, will be 2 and 1/2. Okay? 2 and 1/2 can be made out of 2 and 5/10 as a decimal. So I'm going to use a fraction. It's just easier. 2 and 1/2 plus negative 1/2. Here, it will be easier to start with any number, really, because we don't have a whole number. Both of them are fractions. So let's start with a positive. 2 and 1/2. So I will have to go to 2 and 1/2 more, splitting 2 and 3 into halves. Okay, stop at 2 and a half, and now I'm going 1/2 to the left. So I started 2 and 1/2, and I go 1/2 to the left because my 1/2 is a negative that I'm adding. So I'm going to stop at 2. My answer is 2. Okay, just to show you, since the addends are different signs, I'm going to subtract from the greater one, from the greater absolute value. 2 and 1/2 minus 1/2 will give us 1/2 minus 1/2 is a 0, right? And 2. It's not 0, it's 0 halves, really. And 2 goes down because I don't have a whole number right here. So we'll have 2 and 0 halves, which is just 2. Okay. All right, and we have negative 1/4 plus 4. Again, it's easier to start with the whole number, so I'm going to change the order into 4 plus negative 1/4. I just changed the order both numbers have the exact same signs. It doesn't change that. So from 0, I'm going to 4, and I'm adding negative 1/4. So I will add another arrow, but I will have to go to the left, and that's why I'm going to separate my whole between 3 and 4 into 4 units to be able to take 1/4 away. Okay, and I will stop at 3 and 3/4. 3 and 3/4. How does it happen? Using math sentences, number sentences. I will have to do subtraction since we have different signs here. 4 minus 1/4. Notice the alignment. I'm not writing 1/4 onto 4 because 4 is a whole number, 1/4 is a fraction. Here I cannot subtract from nothing, so I'll have to borrow from 4. 4 becomes a 3. 1 that I borrow, I split into fourths. 4/4 is my whole. And I subtract 1/4 from 4/4, resulting in 3/4. And 3 minus 0 is 3. That's how it became 3 and 3/4. One more here. 1/2 minus negative 3. Again, this is a subtraction problem. All subtraction problems I have to change to additions because that's how it's easier. 1/2 plus negative 3 changes into positive 3. And I'm going to change the order in which I'm going to do these because it's easier to start from the whole number. 3 plus 1/2. So I will have from 0 to 3. I'm going to add another arrow that is 1/2 unit long. So I'm going to split my whole into 2 halves, and I'm going to add 1/2. I'm going to stop here, which is 3 and 1/2. To show you the math here, 3 plus 1/2. Again, notice the alignment. This is addition problem. Both numbers have the same sign, so I'm going to add the two numbers. 1/2 plus nothing is 1/2, and 3 plus nothing is 3. 3 plus 1/2 is 3 and 1/2. Positive answer because both numbers are positive. Okay? Exercise 5. Create an equation and number line diagram to model each answer. Okay. Samantha owes her father $7. Owes $7. She just got paid $5.50 for $5.50 for babysitting. If she gives that money to her father, how much will she still owe him? Okay, so owes $7. The math number that will represent that is -7. She got paid $5.50. It's going to be a positive number that represents positive $5.50. Okay, so we are going to add these two numbers. We will start at -7. So we are writing a vector, drawing a vector from 0 to -7. And we are going to add $5.50. So we'll go back to the right. 5. And since this is 50 hundredths, I will have to split my whole into 100 pieces, which is very difficult to do in this space, and go 50. 50 is exactly half of 100, so all I need to do is to go halfway. Okay, and I'm going to stop at -1 and 50 hundredths. That means that she will still owe him $1.50. Let's see how it works using math. -7 plus 550. I'm adding two numbers which have different signs. So I'm going to subtract from -7 550. Make sure to write 7 with the 2 zeros after the decimal. That's how you will make it correct. And subtract. When you subtract decimals, you have to line them up. Line the decimals up. Okay, So 0 minus 0 is 0. 0 minus 5 we cannot do, so we'll have to borrow from 7. 7 becomes a 6. 0 becomes a 10. 10 minus 5 is 5. And 6 minus 5 is 1. We are subtracting from a negative number, so the answer is going to be also negative. Okay, so our answer, she still owes him $1.50. Okay. At the start of the trip, a car's gas tank contains 12 gallons of gas. During the trip, the car consumes 1 1/8 gallons of gasoline. How much gas is left in the tank? Okay, so contains 12 gallons, that's a positive number, so it will be 12. The car consumes 10 1/8 gallons. So consumes is a negative change. So I can write plus negative or minus positive. So just to show you, it can be minus 10 1/8. But because we don't do subtraction, we change it into 12 plus negative 10 1/8. Either one is correct because they mean exactly the same thing. Okay, because we are working with different sign numbers, I'm going to subtract the absolute values and keep the sign of the bigger one. So 12 minus 10 and 1/8. That's what I do in math. Let's see how it's going to look on the number line. So 12, I have only 10, so I'll have to change this number line and extend it a little bit. 11 and 12. From 0, I'm going to 12, and then I'm adding another arrow that will go to the left. 10 units, 10 units, so I'm at 2 right now, but I'm not done. I need to go 1/8 more. For that reason, I'm going to split my hole into 8 spaces. That's why it's easier sometimes not to use the number line, because number line gets confusing at this point. So I'll have to go this much, just a teeny bit more, 1/8. And I will stop at 1 7/8. It's barely visible, so it's easier to use math equations. 12 minus 10 and 1/8. I cannot take 1/8 out of nothing, so I'll have to borrow from 12. 12 becomes 11. The one that I borrowed, I'm splitting into 8 eighths. 8 eighths minus 1/8 is 7 eighths. 11 minus 10 is 1. That's how I know, and this is a positive number because 12 is a positive number. 1 7/8. All right, last problem here. A fish was swimming 3 1/2 feet below the water surface at 7 a.m. 3 1/2 feet below the water surface. 4 hours later, the fish was at a depth that was 5 1/4 feet below where it was at 7. What rational number represents the position of the fish with respect to the water surface at 11 a.m.? Okay, so both numbers are below the water surface. So I'm going to use addition of two numbers that are both negative. I will have negative 3 1/2, and I'm adding more negative 5 1/4. Okay, this one is tricky because fractions have don't have the common denominator. I will have to change it into a common denominator. If you remember how to add fractions, it's very important. Why is it important here on the number line? Let's take a look. Negative 3 1/2. So I'm going negative 3 1/2 more. So right here, negative 3 1/2. And I have to add negative 5 1/4. Okay, how do I add fourth to halves? I cannot do it. And from here, I probably will have to skip, because from here I will have to count by halves. My whole units, I will have to all split into halves. It will be easier for me to work with. Okay, and I'm going from here 1, 2, 3, 4, 5, and 1/4 more. I will have to split this into fourths, wouldn't I? And go 1/4 more right here. And since this represents -8 and 3/4, that's what my stopping point is going to be. -8 and 3/4. Now this might look confusing, okay? It might look very confusing. So that's why you need to know how to use common denominators when adding fractions. So both numbers are negative. All I need to do is to add them together. 3 and 1/2. I'm adding 5 and 1/4. Okay, this is how math goes. I'm going to find the common denominator for both 1/2 and 1/4. I'm going to just write equal sign here. 3 and 5 stays the same. I will have to change 1/2 into 2/4, multiplying both numbers by 4. By 2, sorry. 2 times 2 is 4, 1 times 2 is 2, and 5 and 1/4 stays. 1/2 is exact same thing as 2/4. Okay, and when you have 2/4 and 1/4, it'll result in 3/4, and 3 plus 5 is 8. Both numbers are negative, so my answer is negative. -8 and 3/4. Okay, for those of you who don't remember, I'm multiplying 2 by 2 to make 4. And what I do to the denominator, I do to the numerator. 1 times 2 is 2. Okay, that's how I got 2/4 out of 1. That is it for lesson 7. That was a long lesson, so if you feel like it was too complicated, too confusing, feel free to watch it again next day, and maybe a couple times more to make sense out of it. Also, as usual, I'm always available to answer all of your questions, so don't hesitate to ask me questions if you have any. Otherwise, I'm going to talk to you in the next lesson. Do your homework and good luck.